My name is Emma Loubser and I'm a structural engineer at PBA Projects in Cape Town. The structural framing makes more sense in the context of what type of project it is. So we've a modular expansion at the Sishen iron ore mine in the Northern Cape. They had pre-expansion, they had a modular structural mine that actually PBA Projects did design on. And pre-expansion, they could only process 3.6 megatons per annum, which sounds like only. But with the upgrade, they were able to process all of the tailings from their jig, which was then the full stream of 6.95 megatons per annum. And so the structural framing, it's not like structures you see every day. They're big steel column and beam structures braced with all different kinds of circular hollow sections, angles, whatever's required from the design perspective. The main challenge would have to be that it was a brownfields project, so we needed to integrate well into an existing site. So there was a short timeline, a small footprint that was constrained by existing structures in an already fully operational mine. So we needed to get around that with some kind of good engineering solution, which happened to be the modular design. So all of the structures were designed in modules that were transportable on the back of trucks and be able to stack together in between all of the existing modular plants already. Within our project group, we have a sibling company, PBA Engineering, which happens to be down the road from us in Cape Town. So what's great about that is all of the fabrication was done at our own site, and we had great quality assurance from all the engineers could just pop down to have a look at the process while it was taking place. And even there within a small footprint, all of the modules were trial assembled. So we got to see how all of the modules stuck together to the finalized product. And then we could water test. So all of the mechanical equipment items were there, excluding screens. We had pumps and all of the sumps and platework items in place. So that was trial assembled there. And then each of the boxes gets disassembled straight onto a truck. So even where process equipment fits through shared modules, there are strategic splits in the modules. It goes up to site, which made the erection part of it so easy and well integrated, because then they just stack it all together again, and our process and mechanical engineers go and do the commissioning on site. The modular design solution is so wonderful because apart from the fact that it really makes site erection times so quick, it shortens the project timeline. It also enables us to fabricate in one place and transport it anywhere. And actually with a modular solution like this, in theory and in practice, which we've seen before, you can assemble it and you can disassemble it and move the plant somewhere else. So it's really a phenomenal solution also because everything comes already fitted out with all of the different engineering components, the electrical, the process, the mechanical parts. Everything's already geared to click together and kind of a plug and play, I guess. But the fact that everything's designed with the strategic splits to fit on the back of a truck, we have to think of a whole lot of different parts of how the structures are designed, with where there's splices, where the connections. So when you put the modules back together, you can easily access the connection points to make it safe for working when they're stacking the modules. And the other aspect that's really interesting about these mining structures, which I haven't touched on yet, is we've got a lot of vibratory equipment that goes onto them as part of the process. So we need to do a lot of harmonic analyses of the structures. And in that capacity, with these modular ones, we're actually able to low tune the structures, which means we save quite a bit of steel in terms of the overall mass. And yeah, they work really well when they get to site with good results that we've seen. I'd have to say I don't think there could be anything else to use for this type of thing. In terms of its modular design aspects, steel connections are ideal. The way the different box sections that almost look like containers without sides with all of the equipment, the way they stack together and interlock, the steel allows for such perfect connections. Also for any of the geometric complexities that we need to overcome, access, maintenance, the way that the equipment attaches to the steel elements, it really is just, there isn't anything that could work as well for this type of design. It really did achieve everything that the client asked for in terms of the process enhancements, but apart from that, being able to integrate into the mine while it was fully operational, particularly in the modular area where we were working, and it needed to bring so many disciplines together and so many complex interfaces between conveyors and third-party contractors doing that and the existing mine. It was just such a really good technical show of how something so complicated could be made to look so simple.